We're meeting as building professionals in the face of a climate and biodiversity emergency. And we've had the World Green Building Council telling us for some time now that buildings are responsible for 39% of global CO2 emissions. So if you add to that the biodiversity decline attached to both the procurement of building materials and the commandeering of previously natural ecosystems to locate our built environments, it becomes really clear that together, as today's cohort of building professionals, we're key drivers of this gigantic environmental and social problem. That said, we can also be key drivers for environmentally and socially regenerative change. So there are three prongs to this approach that we can take in this climate and biodiversity emergency. So firstly, to address the operational impacts of buildings. And that's been the main focus to date that you'll have found. Secondly, it's to address the impacts that are embodied in the construction of buildings. And that's mainly bound up in the procurement of materials. So specifying building materials responsibly has a far larger immediate impact on this climate and biodiversity emergency. And this is what I'd like to focus on in this presentation. Finally, of course, to address the size of buildings, which has the most significant impact on the first and second prongs, but which we hardly speak about at all. So I'll cover each of these before talking about what we can specify by way of building materials that cost the earth less. Certainly the focus of the World Green Building Council until last year, as it was also the Australian Institute of Architects Climate Action Super Forum in Melbourne, which was earlier this year, the focus has been on improving the operational energy efficiency of buildings. And that's towards achieving net zero operational carbon. As that relates to thermal performance, as well as to the efficiency of fixed mechanical and electrical services, as well as loose appliances. So thermal performance is based on benchmarks, which for housing in Australia have been set by the BCA at 6 stars, by Passive House at an equivalent of around 7.5 star for Melbourne's climate zone, by design guidelines for eco-housing estates like Currumbin Eco Village in Queensland, Beyond Today in South Australia, the Cape in Victoria, and Mullum Creek in Victoria. They're also chasing 7.5 star or requiring 7.5 star thermal performance. And then you've also got professional bodies such as BDAV or Design Matters. They've got Sustainable Design Challenge where they're chasing 10 star. Now 10 star implies that virtually no energy is going to be required to heat or cool the house through the year. Even a superficial review of this approach raises a bunch of issues. In 2016, Swinburne Uni and sustainability consultants Pitt and Sherry, they confirmed what some of us had long feared, which is that the value of Australia's home energy efficiency rating system, NATERS, is for the most seriously eroded by lax and optimistic software data entry and by material substitutions and poor construction detailing on site. So these practices can reduce the thermal performance of homes as built quite commonly by 1 to 1.5 star below their certified rating. This weakness in the system can be addressed with a few relatively simple measures, and they were measures we employed for the Mullum Creek eco-housing project in Donvale, Victoria. So there we required that energy ratings to 7.5 star be undertaken using Accurate and by 1 which we nominated an independent and rigorous assessor for all homes across the estate. And once construction was underway, we provided lot owners with a free inspection service to ensure that the thermal performance that was designed into a home was carried through to the final constructed outcome. So both the energy assessments and the construction overview, they were generously funded by the developer, and that's a family of environmental philanthropists. So Sue, Steve, and Danny Matthews. In cool, temperate climates like Melbourne, it's not easy to achieve a genuine 7.5-star energy rating. So that's a thermal performance that almost halves the space heating and cooling requirement that's attached to the nationally mandated 6-star minimum that you'll all be familiar with. We found that homes with anything other than a compact architectural form and a modest amount of well-orientated glazing, they struggle to reach 7.5 stars without all of the following design features in place. They need to have high levels of insulation in external walls and roofs and ceilings. They'd need double glazed windows with high thermal resistance and high solar heat gain coefficient, so that's for Melbourne's climate. And interestingly also, they needed substantial and continuous insulation to the lower or ground floors. Now, I've got my thoughts on how government should act to lock in more respectable thermal performance for buildings across the board in Australia, but I won't bore you with that here. As building professionals practicing in a climate emergency, I'd suggest that we focus on securing genuine as-built, say 7.5 or 8-star homes. We should do that by teaming up with highly competent energy assessors who we employ to consult without fear or favour through both the design, the certification, and the construction phases of our projects. Better that than to cajole them towards a look good but low bang for buck and frankly unnecessary 10-star target. Our energy assessors also need to be paid properly for the substantial work that goes into a truly rigorous service. Okay, so what about building materials? A report was tabled by the World Economic Forum in Davos in 2018, and it put the world's consumption of materials at above 100 billion tonnes a year. And that quadrupled since 1970. And meanwhile, the population of that period only doubled. Between 2016 and 2018, this consumption of materials had jumped by more than 8% just in 2 years. Yet the reuse of materials had fallen from 9.1% to 8.6% of all the material that was consumed. According to the CEO of Circle Economy, Harald Fiedel, who tabled the report, he said, "We risk global disaster if we continue to treat the world's resources as if they were limitless." Now, the lion's share of these materials, nearly 40%, is turned into housing alone. The World Green Building Council also tells us that of all carbon emissions attributable to the built environment, 28% of those embodied emissions are mainly relate to the procurement of materials used to construct buildings. There are no really clear figures for Australia on this, but from e-tool outputs and the work of Andre Stefan and Robert Crawford at Melbourne Uni, I'd like to suggest that the ratio between embodied carbon and operational carbon in Australian building stock is even much higher than the global average that I quoted before. And that's because the floor area that's attributable to each occupant in our homes and our workplaces, as well as the volume of vacant buildings in our cities and at our holiday destinations, they are higher than almost anywhere in the world. You can see from this infographic from Stefan and Crawford that as building size per occupant increases, operational energy use increases as well, but at a lower rate, and that's as you'd expect. Secondly, we have a relatively benign climate through most of Australia, and that moderates heating and cooling loads. And thirdly, our newer habitable building stock in Australia generally has better thermal performance, appliance efficiency, and maintenance than that in much of the developing world, where construction has charged forward to lower performance standards and at a blistering rate. Per square metre of floor area, and I'll stress per square metre, it's fair to say that the operational energy and water efficiency of buildings in Australia is slowly improving. What this means, though, is that the materials used to construct them remain as the primary driver to the overall life cycle environmental impact. So services and appliances, they can be upgraded to embrace new technologies and to provide improved energy and water efficiencies through what needs to be, these days now, a long service life for all buildings. But our specification of building materials commonly comes with more serious and immediate environmental impacts that are irreversibly locked in as construction begins. So if you're building a home today, say a 6-star rated home, sort of the national mandated minimum performance in terms of thermal performance, you can see here the overall life cycle environmental impact and how they are, the relative components of each. So a good half goes into construction and repairs and maintenance, and then the other half goes into operational, operational and emissions and energy use for the life of the building. And you can see here that the thermal performance that then drives space heating and cooling, the stuff that we assess through Passive Pulse and that we assess through the NATA's energy rating tools that we have, is only really a small portion of that, or a minor portion. And then when we go to a 7.5-star home, for example, we're almost halving that space heating and cooling requirement, because of the improved thermal performance. But you can see how, in terms of the overall life cycle environmental impact, it actually it reduces it only a small amount. Yes, if you add solar power, say 4 kilowatts of solar power to the home, you then, in effect, that offsets some of those emissions through the life of the building, and it can bring it down to maybe down by 26%. You can see that solar power on the roof, or photovoltaics, really have a good impact. But again, just the point I'm trying to show here is that the construction is really the dominant element in the overall environmental impact of the home through its life. Okay. If you believe the science as it's presented to us, what matters most now is how deeply and quickly we arrest CO2 emissions and biodiversity collapse. If we don't move mountains in the next 5 to 10 years, our future on this planet will be very bleak indeed. It'll be very hard for us to play catch up to get us back to a livable climate. So if you have a new building in design on your desk, its overall environmental impact across the next 10 years, this period of emergency like none we've ever faced before, that will be tied almost entirely to its construction, because its life cycle operational impacts will have only just begun to take effect in that period. Excuse me. There are tools available to measure and verify life cycle environmental impacts, so embodied and operational impacts, such as carbon emissions, water use, toxicity, ecosystem degradation, from cradle to grave. You'll have heard of those terms. There might be some terrific ones out there, these tools for assessing that, but those that I've engaged with, they can tend to draw on inflexible assumptions about the future. They can produce quite different outputs from the very same entry data, and they result in reports of only limited benefit considering the time and money that goes into them. Certainly we can avail ourselves to these tools, and I expect that they're going to get smarter over time. But in the meantime, in this climate and biodiversity emergency, we must respond to a simple truth, being that cement and concrete products, steel, fired clay products, timber, and swimming pools are currently the most impacting materials to be locked into our builds as they rise from the ground. A couple of thumbnail sums and a good dose of critical and future thinking go a long way to guiding our material specifications towards environmental and social sustainability. So let's start with cement and concrete. The World Green Building Council, Beyond Zero Emissions, and other respectable sources, they all agree that the manufacture of Portland cement accounts for a whopping 8% of the planet's greenhouse gas emissions. So roughly the same globally as the entire transport sector. It's hard to believe, but it's true. But there are alternative, equally effective and readily available concrete binders, such as fly ash, which is a waste from coal-fired power generation, and slag, which is a byproduct or a waste from steel smelting. These alternative binders are collectively referred to as supplementary cementitious materials, or SCMs, and they're now readily available. The Mullen Creek Design Guidelines required that SCMs make up a minimum 30% of the cement used in wet mix structural concrete. And some architects and engineers, they chose to increase that up to 60% where surface finish wasn't critical. As construction commenced on the estate, we found that more and more local batching plants were supplying concrete with SCMs with no increase to supply cost. In time, it should be considerably cheaper, this concrete with SCM, because slag and fly ash are problematic industrial wastes that are otherwise expensive to dispose of. Also these days, we're going further and further from our cities to source virgin rock and sand for our concrete. The sand can't be weathered and rounded in the way that beach and desert sands are, where most sand comes. We see huge volumes of sand. The sand for concrete needs to be angular to create a good structural matrix. And so it's surface mined from recent sedimentary deposits that lie beneath often delicate natural landscapes. In the global context, it's acknowledged now that we're about to simply run out of virgin angular sand. And so research and development for recycling our gigantic hard waste streams to produce both coarse and fine concrete aggregate from them, that needs to ramp up urgently. And as it does, we building professionals need to promptly preference these recycled products via our concrete specification and our ordering. At Mullen Creek, initial resistance to SCMs subsided as concreters found that ground slabs containing SCMs were stronger and with less shrinkage cracking, as they found out that as the shotcrete sprayers learned not to add water so liberally to adjust the workability of their SCM mix on site. So that's the shotcrete sprayers for doing work like swimming pools. And also, as bricklayers and rammed earth wall contractors realised that bagged cement containing 50% SCM, so you can see here Australian Builders Eco Blend, that was equivalent to general Portland cement, both in its performance and the price. My next job is to convince rammed earth wall builders that Australian Builders Steel Pave, which is 85% white slag, will also perform well as a cementitious material for rammed earth walls. And it'll do that without reducing those nice earthy wall colours to a drab grey. So these rammed earth wall builders normally actually use white Portland cement, which is expensive and has an even higher carbon footprint. So steel paves a very good alternative, being a white material as well, a white binder. Earlier this year, I was on the phone with a bright young architect. His name's Rodrigo Roca. He recalled someone from, I think it was Austria, telling him that rammed earth in Australia is not rammed earth, but rather it's just dirty concrete. And I was thinking, you know, he's right. There's certainly nothing environmentally responsible about building a 350mm thick rammed earth wall containing 10% Portland cement by volume. The wet mix for casting a 190 thick hollow concrete block contains only 14% Portland cement. When I was a young bloke, we built a lot with rammed earth and with puddled mud. We put effort into selecting and blending aggregate with the right gradation of particle size and colloidal content to achieve good strength and weatherability for walls without the need for cement at all. We followed the CSIRO, National Building Technology Centre's bulletin number 5, and that's on earth wall construction. And we did the old-fashioned thing of erecting test panels before proceeding with every build. What about steel? I think there's nothing wrong with a sheet of corrugated iron. Coated steel wall and roof cladding provides an expanse of robust and almost maintenance-free cover that's difficult to surpass at less than 0.5 millimetre of material thickness. But check out the embodied energy in just 2 sheets of light SL82 reinforcing mesh for a 120mm thick concrete slab on ground. So the embodied energy, or the carbon footprint of that mesh, is about the same as the embodied energy in the concrete itself. So here it's the 20 MPa concrete with only Portland cement as its binder. When 40% of the Portland cement in that concrete is substituted with SCMs, the light steel reinforcement ends up having the more dominant carbon footprint. Again, you wouldn't think that, but it's such is the potency of steel. Yep, so per unit volume, the carbon footprint of steel is staggeringly high compared to all other common building materials, including aluminium. And you can see here how a 9mm thick fibre cement sheet that normally contains around 40% wood fibre, that has an embodied energy that's significantly under the 0.5mm thick coated steel sheet that we use very, very commonly. So reducing the amount of weighty steel in construction, particularly structural steel, is one of the best ways to minimise embodied carbon. In too many simple structures, I see steel used where substitution with a sustainably sourced timber would have been a cost-saving no-brainer. On some building sites, it's almost obscene. The Mullum Creek Design Guidelines include a requirement prohibiting the use of cold form steel framing, but the use of hot rolled steel is permitted on that estate. I learnt more recently that Currumbin Eco Village in Queensland prohibited hot rolled steel without undue resistance from designers and builders and engineers. So in retrospect, I think we could have done this too at Mullum Creek. Nonetheless, the Mullum Creek Steel Products Guide, it lists steel products that are manufactured locally via comparatively energy efficient ISO accredited processes. Our local eco warrior, Juice Backer, he argues that steel is fully recyclable and so the ultimate framing material. When the day comes that global industry draws solely from recycled steel stock and renewable energy for its resmelting, I might look to agreeing with him. But until then, and it looks to be a long way off, this climate and biodiversity emergency must have us desperately looking to where we can reduce the amount of structural steel that we shove into our builds. We need to start questioning architecture on our drawing boards that relies on highly reinforced concrete and hot rolled steel to stand up. We need to ask ourselves why such structurally demanding designs are even necessary. Are we chasing building heights that are simply unsustainable, also by social measure? Has our architectural flair for gravity-defying cantilevers, has it overtaken our responsibility to design light and lean in response to the emergency that we've got before us? What other less impacting materials could we use for these structures? You'll see it everywhere. Wood is good. Wood, the ultimate renewable. Responsible wood. Make it wood. Well, contrary to popular belief and some heavy marketing, timber can be the very best, or it can also be the very worst material that you'll work with as a building designer or a contractor, depending on where and how it's sourced. If it's sourced sensitively, it can store carbon through and beyond its service life in construction. It can be reused or recycled, or it can be harvested from deliberately planted and sensitively managed forest, helping to maintain healthy ecological processes, sequestering atmospheric carbon, and contributing to the social and economic well-being of rural communities. But timber harvested insensitively can result in serious and irreversible impacts on flora and fauna, on soil health, and on waterways. It can reduce or even reverse the forest system's sequestration of atmospheric carbon, and it can erode the well-being of rural and Indigenous communities. Even before our Black Summer commenced in September last year, deforestation was responsible for some 17% of global greenhouse gas emissions. Unfortunately, the bulk of structural and architectural timbers that we specify in Australia are sourced in ways that contribute directly and indirectly to this forest demise. The laundering of illegally harvested forest woods into massive and opaque timber supply chains, some of it with PEFC or FSC environmental certification. That stands as the largest illicit business on the planet behind human trafficking and narcotics. Over the past few years, our Bunnings stores have transitioned their sourcing of softwood framing timber away from fast-grown radiata pine, from temperate climate Australia and New Zealand plantations, towards slow-grown Baltic pine from cold climate Russian and Eastern European native forests, often native forests. This transitioning has these sort of waves, on and off waves, and I think we're entering into another one in the next few months. The current rate of deforestation of Northern Hemisphere boreal forests, which are the largest terrestrial biome on the planet, that'll have catastrophic impact on our global climate if it continues. So you can see here across the Northern Hemisphere, this massive band of forest, of green, and in there, sort of the red indicates where these forests are losing tree cover. Basically, either it can be fire, it can be, certainly can, but a lot of it is to do with just logging of timber. And the little blue sections you can see occasionally just down the bottom there around just above Florida in America, that there are areas of increased tree cover, the darker blue. In Australia, it's our tall and relatively intact sclerophyll forests from which the durable, stable and attractive native hardwoods for architectural applications are mostly extracted. So cyclical clear felling of tall, wet sclerophyll forests in often mountainous terrain, it depletes biodiversity and other ecosystem services. It encourages a regrowth that's thick with ladder fuels and causes exposure-related dieback of the often lone habitat trees that are left standing. And this then exacerbates wildfire risk as well. These damaging impacts are now compounded also by a hotter and drier climate, as I know you are well aware of as a result of last summer. Just over a year ago, our country's high labour costs and the slowly raising environmental concern saw at least a good portion of Victoria's remnant native forest protected from logging. Conveniently at those times, we, and by that I'm thinking particularly of Bunnings, turn again to the tropical rainforests of poor Southeastern Asian and Amazonian countries for our Kumaru decks and our Merbau window joinery and our Meranti. Sadly, a year is now a long time for a native forest. In the wake of our horrific black summer, the Australian timber industry is now poised to mechanically thin those native forest reserves that remain intact. It's proposed in the name of fuel reduction, overriding state powers by decree of a federal government emergency response. It's even flagged by this popular online magazine for architects. Meanwhile, we've got a chorus of world-renowned forest ecologists and fire scientists in Australia. So people like David Lindenmayer at the ANU, who draw on clear evidence from the field to demonstrate that mechanical thinning of Australia's tall forests won't lessen fire risk, but instead it'll increase it. The timber lobby is powerful, and whilst the central tenet of our global movement to arrest climate and biodiversity collapse is to listen to the peer-reviewed science. So as design professionals who care, let's make something good of our bushfire tragedy from last summer and ensure through our specifications and our site inspections that only timber sourced from trees that are purposefully planted on previously cleared Australian or New Zealand farmland, or timbers recycled from prior construction use, make their way into our builds. This will leave many good timber choices across all architectural and engineering applications, and it'll send a strong message to the now global timber industry that we won't entertain anything other than fairly sourced wood. Mullum Creek, it requires that timbers used on the estate be sourced in accordance with quite stringent environmental and social criteria. Essentially, that they be either on our approved timber products list, that they be FSC certified and from Australia or New Zealand, or that they be recycled from a prior construction use. We've compiled background papers and comprehensive lists of readily available timber products that are suited to all applications and budgets. And these are regularly updated. So check them out on the website. We've been really pleased and a little surprised with how designers and particularly builders at Mullum Creek are with minimal resistance embracing the sustainable timber products we're requiring them to choose from. And we know they're carrying this new product awareness also to their other jobs beyond the estate. And that sends a strong message to the timber industry that a new generation of designers and builders will only entertain wood that's sourced with true environmental and social responsibility. Over the past 5 years, pretty well everyone in my office has volunteered with CERES. That's the Centre for Education and Research in Environmental Strategies in East Brunswick, Melbourne. And they volunteered there to extend the timber initiative from Mullum Creek into the launch of a new social enterprise, CERES Fair Wood. The profits from CERES Fair Wood all go back into CERES Community Environment Park. Fairwood removes itself from the adversarial native forest debate and from opaque environmental certification schemes. Peter and Hayden at Fairwood aggregate and retail timber inside short local supply chains with Victorian and Tasmanian tree farmers and portable sawmill operators who they know personally. These are mostly small producers who are geographically dispersed and alone or singly, they struggle to find, sell and deliver to a market that's going to fully appreciate the farm-grown trees and the timber that they've got on offer. So Fairwood buys only from growers and millers who source wood to the highest standards of environmental and social responsibility, as it's informed by the Mullum Creek project. Fairwood shares the stories of these growers and millers directly with its customers, who are building and landscape contractors, furniture makers, and of course DIYers. Fairwood Business builds direct friendships and understanding between city and country folk, and it encourages farming families to revegetate their bare paddocks with trees, both for conservation and for profit. And the customers, they're assured the supply of the most environmentally and socially responsible products that Fairwood can source as a not-for-profit social enterprise whose proceeds feed back into all the other terrific things that happen at CERES Community Environment Park. On its website, you'll see that Fairwood has a limited selection of farm-grown and salvaged woods that are available as decking, wall cladding, flooring, joinery and landscape timbers. It's also recently acquired a substantial warehouse that'll now allow it to gather larger and broader stocks of very responsibly sourced wood. In the next while, I'm hoping to support Fairwood to become also a timber broker. So as an extension to the CERES Environmental Charter, Fairwood will provide designers and builders with project-specific timber schedules based on architectural and engineering documentation that's submitted to it. This service could also extend to takeoffs, ordering and even arranging delivery of product to the site for an entire project if that's what's wanted. So some of this timber, it might be from fair wood, and the rest would be sensitively sourced from elsewhere. The bottom line would be that the customer is assured timely supply of quality timber via a not-for-profit agency that's got a strong buying power, it's got non-vested knowledge, and it's ethically placed to aggregate environmentally responsible timbers. And finally, we're advised by the ABS that 40% of all Australian waste to landfill originates from the building industry. That's a huge amount. On the Mullum Creek website, you'll also find a terrific guide to help reduce business as usual construction waste to landfill by 80%. The guide includes both DIY and outsourcing options for waste minimisation. For me, the only really disappointing thing about the Mullum Creek project was our failure to cap the scale of homes built. I think it was the high value of land and the status quo of monster homes in this peri-urban setting that made strong containment of house size on the estate commercially undesirable for the developers. Another terrific infographic by Stefan and Crawford shows how in just 26 years between 1984 and 2010, house size across Australia nearly doubled from 50 square metres to a gobsmacking 87 square metres per occupant. How much house is enough? How much of the Earth's material and energy resources are needed to comfortably house an Aussie? There's nothing sustainable about an 8-star 400 square metre home. Going forward as building professionals who care, can we simply refuse to serve clients who ask us to work on homes that already have or will have a floor area greater than, say, 60 square metres per occupant or per bedroom? By now, I guess some of you might be hating me. Can we at least impress on our clients that quantity of construction drives precious material consumption and carbon footprint upward, whereas quality of construction, it calls on smart design, on craftsmanship, and good work for people, rather than on the limits of our planet. Putting concern about building scale aside, the Mullum Creek project will certainly serve as an exemplar for site-sensitive building and landscape design. It'll showcase energy-efficient architecture, and it'll promote the use of environmentally responsible building materials. So the things that you'll see in place on the estate. But I reckon its bigger legacy will be in published and freely shared learnings, which is a welcome change from guarded IP. And the advancement of people, so lot owners, designers, builders, who've been able to engage with the project. Just the other week, Design Matters awarded this home at Mullum Creek the 2020 Australian Building Design of the Year. So all the quite rigorous ESD requirements that guide the design and construction of homes at Mullum Creek, including those I've flagged here on material selection, they still leave plenty of scope for fine architectural expression, as you can see here. Okay, to finish off, I'd quickly like to take you through a few other jobs of mine to illustrate a bit more how the materiality of buildings can support sustainable futures. Some years back now, I worked at Candlebark. It's a small independent school established by John Marsden, who has also written a string of novels for teenagers. the Tomorrow series being the most popular. John was mad enough to believe we could build a wildfire shelter for the kids in the forested setting of this school site. So a shelter that could also double up as a school library for the same money as was available at the time for new template school buildings that were funded under one of Kev 07's GFC Buster programs. We actually managed to do this because we were able to keep the whole creative adventure within the local community, the school community. Our structural engineers were at first insistent that 1/2 metre of soil on the roof of this building could only be held up by steel and concrete. And I've explained to you how potent the manufacture of those two materials are in emission of greenhouse gases. And as you can see here, I remain stubborn to my love affair with wood. The carbon dioxide emitted to the atmosphere in production of cement for the concrete floor and rear walls of this earth-covered structure, it's been fully offset by the carbon dioxide sequestered from the atmosphere by the plantation pine that makes up the timber roof structure. Whilst there's some complexity in design detail of the radiating timber portals, this detail repeats itself throughout the building. Again, many a timber engineer would argue that shaped timber portals like these need to be fabricated off-site using some very fancy machinery. The business behind off-site fabrication often benefits only a few people who have the capital to invest in such expensive equipment. You won't see many people employed on these factory floors. When we speak about sustainability, we often focus on environmental sustainability, but social sustainability is the other key to a future that's kind to our natural world and that's equitable for all people. And for the most, capital-intensive industry is not as equitable as labour-intensive industry for obvious reasons. Portals for this school library turned out to be an inexpensive 2-week fabrication task for just one very smart country carpenter, Russell, and his apprentice, Jared. And they just used basic powered hand tools in a nearby farm shed to the school. So there were no robots here. The portals then took only 3 days to erect on site. And you can also see here how the 5 billets of LVL that make up each portal have been screwed together. So we avoided glues in this lamination process. And that means that these LVL billets can easily be dismantled and repurposed when the building comes to the end of its useful life. Designing for material reuse saves on natural resources. So that's a good objective to follow. And all the LVL offcuts from the shaping of the portals were ripped up into purlins, which in turn were then screwed down onto the portal beams. And before then, those same LVL purlins and the structural plywood roof substrate, which is Carter Holt Harvey EcoPly, it had a pre-use as temporary formwork for a concrete slab beam that provides lateral restraint to the curved reinforced concrete block retaining wall that runs around the back and the sides of the building. So minimising material wastage is another important objective in sustainable building design. I'm not a great fan of green roofs and walls when they're incorporated at height as a shroud to a city building. But site constraints here made it sensible to have this school library come wildfire shelter constructed into the side of a hill with an earth-covered roof. In combination with substantial insulation that was necessary for the southern climate here, this earth cover provided exceptional thermal performance and obviously terrific wildfire resistance. At Candlebark School, I could see that design technique and construction method kept simple and accessible to local people, in this case the school community. It allowed them to maintain command of and pride in the whole of the creative process. And whilst I've spoken highly of some engineered wood products, be mindful of capital-intensive material manufacturing processes that don't necessarily improve social sustainability. Keeping things simple can help to share work, skills, and wealth more broadly. And post-COVID, I think this will be really important. I spent the first 10 years as an architect up north, helping Indigenous communities to design and build for themselves using materials straight out of the local bush. So stone, earth, and crushed anthills, bamboo, as well as raw pole and chainsaw mill timbers. And we adapted simple construction methods that were suited to the community workforce. And they were men, women, and children, all with different levels of health, strength, and skill. It was stacks of work, but these people had time on their hands and they were keen to learn. And so by this self-help approach, they got to own their own homes, and they were built at a tiny fraction of the cost of pretty crappy government-built homes that they'd otherwise need to rent. Here, local materials and simple work methods built good homes as they built community and social resilience. In other words, architectural process can engage materials for economic, social, and environmental sustainability. These days, it's too easy for me to get knotted up in unnecessary design complexity. But I'm not suggesting that we must go back to basics and shun new technologies. Check out this fabulous enterprise in the USA that I stumbled across last week. So Holst Trees Structures, it marries 3D scanning and BIM technology with the natural beauty of trees and the unsurpassed strength and minimal waste of timber when it's used in the round. In doing that, it can elicit exquisite biophilic architecture from designers like you and me. I just love it. And finally, when we're looking to materials for sustainable futures, we could propose that a green building needs to be one that's already there. We should delicately rework existing buildings where we can, apply our finest design skills to minimise natural resource depletion and to give our planet a chance to heal. Except that a gentle architectural touch might not catch the eye of today's glossy magazines, but know that the future life on Earth will be thankful for it. So thanks everyone for listening to this webinar, and I hope we've still got time for a really good Q&A. Thank you.